In this video, we are going to be identifying true statements involving subsets and proper subsets. And I will tell you the meaning of those in just a second. So let's look at the notation first. Okay, so this little sideways U with a line under it, it reads is a subset of. Okay, is a subset of. So like this one would read 11, 12, 15 is a subset of 11, 12, 13, 14, 15. Okay, so that's how that reads. If it doesn't have the line underneath, it reads is a proper subset of. Okay, so the only difference between a subset and a proper subset is that a proper subset has less elements than the original set. Okay, so if it's a proper subset, it has to have less things in it than the thing that you're asking is it a subset of. Okay, so it can be a subset and you can be a proper subset at the same time. Okay, but if you can also be a subset without being a proper subset. Okay, so if you have the same amount of members in both things, then it's not a proper subset. This with a line through it means it's not a subset, okay, which means there are things in one that aren't in the other. And then, of course, the zero with the line through it is the notation for the empty set. It's the set that has nothing in it, no elements in it. Okay, so let's take a look at this. We've got our first question here. This is a true or false statement. 11, 12, and 15 is a subset of 11, 12, 13, 14, 15. So all we have to decide here is are the elements 11, 12, and 15 found in this over here? Okay, and if the answer to that is true, then this is a subset. Okay, this one would have also been a proper subset because all three of the elements are included here, and there's less elements here than there are here. Okay, so it's both a set or a subset and a proper subset in this case. Okay, the empty set is a proper subset of this 4, 5, 6. Okay, the empty set is a proper subset of everything except for itself. Okay, so basically you can think of it as nothing, and is nothing a proper subset of something? And that is true. Nothing is included in here because it has something in it. So this one is true. Okay. This one is asking, is PUX is not a subset of PUX. There should have been a comma there. So PUX is not a subset of PUX. That is not true. PUX is a subset of itself, PUX. It's just not a proper subset. Okay, so it is a subset because it contains all the elements in this, contains all the elements that are in this. So it is a subset. It's just not a proper subset. So this one is false. It is a subset. And then last, we've got CDFG is a proper subset of DG. Okay, this one is false because this can't be a subset of this because this has more things in it. Okay, so if this thing were turned around, if the DG was over here and the CDFG was over here, then yes, it would be true. DG is a proper subset of CDFG, but it's written backwards. Okay, so you can't have more members and still be a subset of this. Okay, so that one is false. Okay, let's look at the next one. So we've got the statement, CFH is a subset of CDFGHJ. Well, C is here, F is here, and H is here. So yes, it is a subset. And it is a proper subset. If you were asked that question, that would also be true. Okay. And this is almost the exact same question we got asked on the first one. Is the empty set a proper subset of RTW? Yes, it is. The empty set is a proper subset of everything except for itself. Okay, so that one is true. Okay, 13, 16, 18 is not a subset of 13, 16, 18. Okay, that one is false because 13 is included here, 16 is included here, 18 is included here. So all the members here are also found here. So it is a subset. It's not a proper subset, that's for sure, because you would need less members. So if we took out one of these and made it just like maybe 16, 18, that would be a proper subset and a subset. But since all the members are there and they have the same number of things in them, it can't be a proper subset. But it still is a subset because everything here is found in here. So this is false. This is saying it's not a subset, and that is false. It is a subset. And then last, is 1, 2, 3, 4, 5 a proper subset of 2, 3, 5? No, for the same reason as last time. There's too many members here. There's more members in this than there are in this. So this can't be a subset at all of this because it's got too many things in it. Now, if this were written backwards and turned around, would 2, 3, 5 be a proper subset of 1, 2, 3, 4, 5? Yes, it would. But it's in this way, it's written in the wrong order. So this is false. Okay, let's look at the last one. So the first one says 11, 13 is a proper subset of 11, 12, 13, 14, 15. In order to be a proper subset, all these things have to be here. So 11 is here, and then 13 is here. So those are included. And this has to have less elements than this. Both of those things are true. So this is true. Okay. Next one, 1 and 7 is a proper subset of the empty set. Well, the empty set has nothing in it. Okay, so 1 and 7 cannot be part of something that has nothing in it. So this is automatically false. You can't be a subset of the empty set unless you are also the empty set. So that's false. Okay, PRV is a subset of PRV. Yes, that is definitely true because all the elements are found. Okay, so P is here, R is here, and V is here. So it is a subset. It's not a proper subset, but it is a subset. Okay, and then the last question here, we've got CDFG is not a subset of DF. Well, that's true. That has to be true because there's more elements here than there are here. So this can't be a subset of this. So that is a true statement.